Okay. Hello there. I'm Josip Antolis, and I'm a principal engineer in Infobip. There, I'm part of our infrastructure team. That means that I help other product development teams build their products better and faster. In particular, I work on our API infrastructure. That means that I kind of maintain and take care of our runtime component, our API gateway, which is kind of like a reverse proxy that balances over all of these microservices in the backend. I also help out with API governance. That's our program for educating developers how to build better APIs and kind of reviewing their work afterwards. And then on top of these well-designed, hopefully, APIs, we add a layer of extra stuff on top. So that's like our reference documentation for the API, but also these API client libraries, which basically abstract the HTTP part of it, the JSON serialization, stuff like that from the clients, who can then just consume APIs more easily. And then we have a whole stack of SDKs on top of these client libraries, which I won't go into details today. So I know that this can be a little bit abstract, so I'll start with a concrete example. And in this example, we'll take a semi-hypothetical team. Now, this team also designs some APIs, does some API governance, and then one day they are approached by a client who asks them to build a Java library. Now, team knows Java. They say, OK, we can build this Java library. They start coding, and within a couple of sprints, they have a nice little library, and they publish it not only to this one client, but also on GitHub. And there they get some stars, some forks even, and moderate success. But with time, they start receiving kind of feature requests as well. And other clients are asking them for support for additional API endpoints in their library. So they go back and they start expanding this library, adding feature to feature. And then they get more weird requests for some other programming languages. Now, this team, they may know Python, so maybe they can develop a Python library, but they certainly can't cover everything. They don't know all the languages, so they go to hiring. They hire more people, and they start working on more and more libraries, so now they're publishing various different stuff. And their backlog just keeps growing and growing. And here, what happens is that for every new feature on API, they need to add support for it in client libraries. And whenever adding a client library for a new language, they need to support all of these features, all of these API endpoints. So it's kind of a combinatorial explosion happening in their backlog. They just can't deal with it, and the slides keep on running. OK, weird. And they just can't keep up the pace with this development, and it's not particularly interesting development. It's just adding support for these endpoints over again. So I said this is a semi-hypothetical team. That means that it didn't really play out like this with Infobip. So we could kind of foresee it happening, but we stopped and regrouped and came up with another plan. So what I'm going to talk about today is kind of our path from API to client libraries. It works for our use case. It may work for yours as well. Or you may just find it, I don't know, interesting to see. So with this example fresh in our minds, let's try to kind of find what are the biggest challenges for this semi-hypothetical team. And now, one of the challenges is this continuously expanding API library. We are continuously adding new endpoints to our API, and we continuously need to go back and re-implement them in the library. And next up, we have this continuous need to support new programming languages. So we continuously need to add more and more, libraries. And if you think about it, this is actually a good problem to have. It means that we are expanding to meet kind of new needs of the market. Let me just restart my presentation. OK, sorry about that. So we need to constantly be kind of adding new programming language support, and we need to constantly be adding new API endpoints to our library. And we actually want to do that. Why? Because it means we have a growing business, OK, so we need to support more features. And we have a diverse customer base who use different programming languages, so we need to support them as well. So these are kind of good challenges to have, but we need to think about them systematically. So we can't just hire our way around it. So whatever I keep talking about in this presentation, always keep these two challenges kind of in mind and think of everything through that context. So for the plan, we need to come up with a plan to actually solve these challenges. And here I'm going to start with the business goal and then translate it into a technical goal. So first business goal is ease of integration. Okay, we want clients to integrate with our API more easily, regardless of what programming language they are using. So here comes this requirement for supporting arbitrary programming languages. Okay, and next up, we want to have workload optimization. Now, this is just a business speak for kind of avoiding this combinatorial explosion in our backlogs. Okay, and we've seen why this combinatorial explosion happens. It's because we need the support of a lot of API endpoints and a lot of these languages for the library. So to deal with that, we need to kind of automatically generate the library source code. Okay, we can't just keep doing it by hand. We need to programmatically generate these libraries. And this is the core idea of our approach and consequently of this talk. But it's not the only idea. We also want quicker time to market. Now, for our product owners in the organization, libraries are a way to drive adoption of new features. And we can't do that if our inclusion of these features in the libraries is lagging behind their availability on the API side. So for all of these different changing API endpoints and all of these programming languages that we support, we need to have some sort of automated pipeline which actually kind of automatically publishes this stuff and publishes the packages to their repositories, etc., etc. And last but not least, we want some sort of code correctness. Okay, so we want the generated library to actually be correct when you generate it in any programming language that we choose, but we also want it to be backwards compatible. Because remember, we want to drive adoption of new features, which means that our clients need to be kind of feel safe upgrading versions of our library, which means we need to be backwards compatible, and we need a set of regression tests to verify that. So we need some sort of automated regression testing there as well. So we are building an automated pipeline that will generate the library source code and will actually include some regression testing in there as well. So to do that, we needed some sort of protocol to describe our API. And for that, we picked OpenAPI Specification. Now, that's an open standard, and we'll get back to this open part later on. But for now, know that we use it to describe every part of our API. And we put all of this information in one large JSON or YAML file. So all the paths, all the HTTP methods, request response body schemas, everything. And then this file, this JSON, describes our entire API service. And we can use that in our Oscar project to actually generate the library source code. So the Oscar project for us is the one actually generating these libraries. So what is it? It's a Java microservice first and foremost. And it being a microservice, it means it's accessible to, well, developers in the company as a service, but it's also accessible to a broader automated pipeline. So we have this pipeline which actually calls this microservice when it needs to generate library source code. And the Oscar service, it takes OpenAPI specification as an input, and then it produces the generated library source code as an output. Okay, so that's what it does. Let's now see how it actually does it. So first stage is actually fetching the OpenAPI specification. And that's just a large JSON file. We fetch it and then work with it. Nothing special there. Then we do some pre-processing, and we'll see why. After that, we get a cleaned up OpenAPI specification, and we use that as an input to our most important stage, that actually generates the programming libraries, the library source code. And then after we have the source code, we do some post-processing on it. So we clean up this auto-generated code to make it look more native. And then we need to save the generated source code, so we need to save these libraries somewhere. So this is a broad overview. We'll now jump in and see details of each of these individual steps. So fetching the API is not that interesting, so I'll skip it. First stage is actually pre-processing. And in this pre-processing, remember, we want to support a large API surface, and we need to do it for many programming languages. So let's say some developer changes a piece of metadata in their OpenAPI specification, and it may not be visible on the HTTP API side, but maybe we use this metadata as a name of a package or name of a class. We actually need this little controls point over here so that we can tweak it and remain backwards compatible with previous versions. And also for programming languages. Consider reserved keywords or just naming conventions in general. So we may need to tweak the OpenAPI specification a little bit in order to make it kind of fit better with a given programming language. So that's a pre-processing. Output is actually cleaned up OpenAPI specification. Next up, we want to actually generate the programming, the API client libraries. And for generating them, we are using OpenAPI Generator. Now, what's that? It's an open source community project, and this is where the openness of the OpenAPI comes into play. So we are actually benefiting from a whole open source ecosystem around this specification. And OpenAPI Generator is one part of that ecosystem, which is basically a Java library, which meshes well with Oscar being a Java microservice. And it's based on the OpenAPI specification, which we have for our API. So it fits our use case very well. And one great thing that we get from this generator is support for many programming languages. So it brings in support for more languages that we actually support currently. So we have a lot of room to grow there. So what does this support actually mean in practice? Well, it has a set of mustache templates. These are just templates describing parts of the API. So let's say we have some request body, and then in these templates for, let's say, Java programming language, we'll have a template for building Java model, Java class for the request. For Go programming language, we have a template for Go structure for the same thing. And then we take the OpenAPI specification, and we actually fill these templates with, exact fields of type, I don't know, string and name, phone number, etc., etc. So the combination of the specification and these templates is what actually generates the library. So that's OpenAPI Generator, an open source project that we are using. Now, how are we using it? Or how are we, let's say, customizing it? Well, all of these templates, all of these supported programming languages, they come with a little bit of their own configuration, external configuration that we can tweak. That's used to, let's say, turn on some features in the templates or stuff like that. So we have kind of custom bit of configuration for all of these programming languages that we support. And then we go one step further. We actually customize these mustache templates a little bit ourselves. Now, why do we do that? Well, to tweak it so that it fits our use cases a little bit better. So, for example, let's say all Infobip APIs use the same datetime format in their strings. So here, if a template exposes this datetime format for users to customize, it wouldn't make sense. Users would just have to put the same format everywhere. So we go in, we tweak these templates a little bit, and we hard code this format. So that's just one example of the tweaks we do. But this does represent some bit of work that we need to put in upfront before actually rolling out and generating a library in a new programming language. So before initial release of library for a new language, we need to tweak these templates, and we need to provide some external configuration. But that's all. After that, we are just generating stuff. And then we have these post-processing steps. Now here, we want to, for one, make sure that the generated library is actually correct. So if we can, we want to compile the generated code. And if we can't, well, at least we want to lint it. Okay? And then maybe we want to optimize it a little bit. So let's say we want to remove unneeded white space or unused imports. And all of that is actually very hard to do if you don't have the, development tooling for a given language. And remember, Oscar is a Java microservice. So it doesn't have, I don't know, Golang tooling or Python tooling available to it. So in order to deal with this, we are actually using Docker. So Oscar will on demand boot up Docker containers with images that have tooling inside of them. It will then mount the generated library, do compilation, linting, everything, and we end up with a final library form. So this is the last point in this pipeline where the code is actually kind of changed. It's linted and improved a little bit. So that's our post-processing. And the last thing that we need to do is actually save our generated libraries. And for this, we are using Git, and we are actually committing the library source code into our internal Git server. And this is very powerful for us because it allows us to plug into our standard CI pipeline. So after this step, our generated code is virtually treated the same as any other code written by hand in the company. So we plug into the same CI pipeline that we have available. So let's take a look at how this looks like. We have OpenAPI specification, and we have these kind of language-specific config and templates. We use them as an input for the Oscar service, which generates the libraries and commits them in our internal Git server. And then we have this standard build pipeline for various different languages in our CI server. We use Jenkins, which actually takes this generated source code and builds kind of packages for them. Those are Maven packages, NuGet packages, whatever language we are dealing with. And then it uploads these build packages into our internal package repository. These steps are same for like all the source code that we have in the company, nothing special. And once we have kind of built libraries, we actually run those regression tests, if you recall. We built regression tests for now by hand, and they are more or less always doing the same thing. So they boot up this HTTP server as a mock for our API, and then they use libraries from client perspective to actually make requests against this mocked server, and they can verify the requests, and they can verify the API response, responses from the library. And we never change these test cases when we run this pipeline. So for each run of the pipeline, all the existing test cases need to actually pass. And that's how we know it's backwards compatible, and we can proceed to the publish step. In publish step, we actually automate publishing of all of these all of these packages to their respective repositories. So with many different programming languages in play, this can be a little bit complex, so we script everything, and we can publish, without any kind of manual steps. Now, publishing step is still triggered manually. We don't want it to happen kind of, accidentally, but publishing then, after it's triggered, it happens kind of automatically. So that's what we did. What are the results of this? So we are currently generating libraries in 5 different programming languages, and we are always working on expanding this list. Plus, we support kind of 3 major parts of Infobip API. We have support for SMS, of course, but also email and WhatsApp channels. So you can use these libraries in 5 different languages to kind of manage these channels. So let's quickly go over our goals and see if we actually achieve them. So we wanted arbitrary programming language support, and we kind of have it. So we still need to do some kind of manual tweaking of these templates, but we kind of have this arbitrary programming language support. Next up, it's our auto-generating code requirement, and yeah, we are auto-generating it. That's what this pipeline does. Next up, it's automated pipeline, and again, yeah, we have it. It's running automatically nightly, so it happens all the time. And last, and maybe where we have kind of most work still to do, is actually automated regression testing. Now, as I've said, these regression tests, they do run automatically, but they are still handwritten. So we still write all of these test cases for every language, for every API endpoint by hand. And this is where we are actually looking to expand our kind of implementation further. Maybe we can use OpenAPI specification itself to kind of statically detect breaking changes. Maybe we can automate generation of these tests as well. This is kind of current development for us. But we have these tests running right now, so we have some kind of guarantee of this backwards compatibility. So it's that. Maybe we can try a little demo. So I'll just try running Oscar service locally. As I said, it's a microservice and we run it in our cloud, but it's inaccessible for me here on the stage, so I'll just start it locally. And you can see it's a Spring Boot Java application, nothing special so far. And here, in this pane over here, I'll actually generate the libraries in this directory. So this is actually a Git directory. Whoops. And you can see it's empty. It just has some initial commit, and there is nothing here. So this is where the generated code will appear. And now how do I trigger the generation? Well, basically, there is an HTTP endpoint on this service, which I can just curl and trigger this generation process. So you can see here, some of the steps were relatively quick. So the fetching of the specification worked fine. We applied our preprocessor chain, so we got cleaned up specification. We generated the library source code, and now we are doing this post-processing, which is actually compiling the code and linting the code, etc. And in fact, I can check the Docker containers currently running on my machine, and we can see this Infobip Oscar Java 8 Maven image over here. So that means that we are currently kind of compiling our Java project, which is made to support Java 8 as a minimal version. So once it finishes, hopefully soon, we'll get our libraries generated, and then we'll be able to kind of look into the library, see what it looks like, and try it in practice. So the generation is done. Let me list my directories again, and you can see the generated code appeared here. And in fact, we can see this one additional commit over here with a little bit of a summary of whatever happened just now. So let me go into our generated Java library right now. For now, it's kind of mono repository of all the libraries. And in particular, this is kind of everything we have at the top level of the Java library. And as you can see, we have kind of POM XML file here. Well, that means that our library is a Maven package. Which means I should be able to kind of Maven clean install it locally. Hopefully this passes because that's what happens in this Java preprocessing step over here. And yeah, indeed, the build succeeded, and I now have locally built this package. So maybe let's take a look at its source code a little bit. Okay. Okay, first of all, we have some nice README file here, and we can see how to, I don't know, declare dependency to this library. And I'll just copy this version from here. You see it says local something something. That's just because I was running Oscar service locally, that is the version it puts in the generated libraries. So let's take a look at some of its source code now. This is actually the Java class for interacting with the API, for making API calls. And if we take a look at some of the public methods down below, okay, send SMS message. This is a nice method for actually sending the messages. We can see it has some Java doc here, so it's documented. And, you know, it's using standard Java, you know, POJOs for request and response models. If we take a look at that, we can see these POJOs are also kind of well documented, so it's kind of easy to use this library. It also throws some exceptions, so we use standard kind of exception handling flow for Java. And you know how it happens with Java. It's somewhat old language, so this is a synchronous method, but we also provide kind of several options. One of them is actually asynchronous. So you can use the library to make asynchronous API calls and not wait for the API to process the request. So this is what library looks like. Let's see what it looks like to actually use it from kind of a client perspective. And for that, I've prepared a little project here. It's a Maven project. And let me just change to this version of the library that I've actually built locally. Okay. So with that, my POM should be okay. And now let's take a look at the actual source code of this little showcase demo application. Well, it has a main method, and here I instantiate our API client. I fill it up with some credentials. I create a message, which is actually, sending this hello from Shift text to my own phone numbers. And in fact, I'll prepare my phone over here. And then later on, we can see the sending of this message. And in fact, here we can see Java doc, the same Java doc for this send SMS message, which we've seen previously in the generated library source code. And again, we have standard error handling flow and everything like that. So I'm going to run this right now, and hopefully I should receive the message on my phone. I don't know if you'll be able to hear the notification sound. Hopefully it's loud enough. Okay, here it goes. Demos, right? Let's try this one once again. Or maybe it's my internet that I lost. Using APIs usually requires an internet connection, folks. Keep that in mind. Okay, I'll just retry it once again. If it works, okay. If not, I don't know. You can imagine it happening. Okay, so I guess my internet is just too slow over here on stage. But anyways, this is kind of the final step. We actually send the messages. You can do it as well. So here we've seen all the steps, well, almost all the steps that go into actually generating these libraries, and I have it on my laptop over here. So that's the demo part, and of course, if you'd like, you can kind of join us and help make this libraries project even more awesome. As I said, we are focusing kind of on these backwards compatibility aspects, plus we are constantly looking to expand support for various different programming languages, various different API endpoints. So that's what you can actually help out with. And that's all from me. So thanks for attending, and hopefully this is or was interesting to you.